In this episode of FUM0033 machining, we are going to talk about reamers. Yes, reamers. I'm going to go through some reamer types that I know of, and then we are going to ream one hole. Well, probably I don't know anything that I'm talking about, but hopefully you can follow my thoughts about this. So, let's go on with my knowledge about reamers. Okay, as far as I know, reamers are normally used to make the hole round and also into an accurate size. And they are not very suitable for making a hole. You first use a drill or a bore in a lathe or a boring head in your milling machine. After that, you could ream it. Reamers do not straighten the hole. If the hole is not straight, perpendicular, it won't make it any better. It will follow the main line of the hole. It won't do it any straighter. So the original hole must be straight. Okay. And what are now the different types of reamers that I do have and which we could use? Well, first of all, we have this type. Well, I show it a little bit nearer. Hopefully you can see it. These are the cutting edges, and this one is a little bit well, not in a very good condition. This is a bigger one. These reamers are meant to be making straight holes, making straight holes even straighter and even rounder. Well, this type of reamers and probably any kind of reamer, you don't turn it backwards. If you do that in your hole, you probably can destroy your reamer. So when you are buying like these are used, these might be already ready to go, so to say. And then we have adjustable reamers. This one is nominally 10 millimeter reamer. You can adjust it by this small knob here. Not a lot. This one has a very narrow adjustment range. It's only to make it super accurate. With this one, it's very easy to make a very accurate 10 millimeter hole. Okay. Then you have, and in here you can probably see the top of it. I will show it. I show it now. When I find the correct tool to take it apart this a little bit. This one is also an adjustable reamer, a little bit bigger. This one starts from 31 millimeters and goes up to 37 millimeters. And you simply adjust it by moving these blades. These blades are tapered under. And when you move the blades like this, you loosen it here. At this end they are smallest, and when you adjust them, you need a little bit force here, so they move that direction, and at the same time they spread out. And this way, this is adjustable. It has a very large adjustment range, and yeah, we are going to use this one today. Okay, so these are all these reamers I have been talking are for making round holes which are straight. Then there is an entire different category for reamers which are used for, oh wait a minute there, which are used for making taper holes. For example, taper pins. And then you might need something like, let me take a few examples here. Okay. They can be really small, like this one. This is a tapered reamer. Then they can be a little bit larger, like this one. Well, but it's yet a tapered reamer, and as you see, they can be a little bit larger, like this one. This is also a tapered reamer. And this one is special because when you it looks like it would be a left-handed drill, but actually it is so that it pushes the cuttings away down into the hole. So yeah, so you better have a true hole with this one. And why this is so long and why these are so long? Well, it's not long, but it's relatively long. So this is because you adjusted the correct taper by just reaming more, and then fit the taper pin there and do it more, fit again until you are satisfied with that one. Then there you are. Oh, well, I have a few of these. Then yet another I do have a few, no, only this one. I have two couples of these. This one is I don't know what cone this is, but what taper. It might be Jacobs, but I doubt it. I don't know. I have to figure it out. I have two exactly the same, like this, but these are normally used. For example, if you want to make a decent Jacobs tapered hole, this one is the correct thing to do it. It's easiest. Of course, you can do it with the compound in your lathe and then fiddle with that one. But this one makes it, this type of reamer makes it in one go, and you are good to go. Nothing strange about this. Okay, so 3 types of reamers: fixed reamers for straight holes, adjustable reamers for straight holes, and then taper reamers. All have their uses, and the general rule is that you don't want to bore the hole with that one, so the hole should be as near as possible to the final size, and after that you just make the finishing touches with the reamer. And you never ever, never turn it backwards. Okay, to the reaming job in hand. So what we are going to ream is this. There is this hole. I'm going to ream it exactly to 33 millimeters. It's now 32.25 millimeters. So we are reaming off 0.5 millimeters from it. Okay. Well, as you remember, I had a plan to use ball bearings. No, I don't. Well, this morning when I woke up, I decided no, that's not the way to go, because it makes the shaft really flimsy. And this one is not a very good idea in a place like that. It's better to have a good fat shaft there, which will hold the forces well. Well, and then to make this oil tight in a way, I need to ream it the hole to a certain diameter. I already have done boring on this one, but this material is horrible to bore. It's the surface finish inside here is how would I say, not the best possible. So therefore we are going to ream it and to the desired size. And after that we are going to make the shaft for a suitable size, and hopefully this time the surface finish is not like that. That's a monkey business. So yeah, okay, this one is now I'm going to ream it in very small steps, and my target diameter is well, it doesn't matter actually, but I would like to make it some exact millimeters. Therefore 33 millimeters is a very good goal here. So, and it's all about hand reaming. So let's go on reaming. Yes, and the measuring tools we are going to use in this operation. First of all, the always reliable meter tire quesometer. Well, this one we can use to check whether we are approaching the goal. And then this one everybody knows. This is a snap gauge. This is a very accurate tool when used in combination with micrometer. Well, this is a cheap Chinese. Unfortunately, I didn't have a better micrometer for correct measuring range. So we have to do with that one. So our first task is to measure the hole now. And let's see what's the size of this. Hopefully, I probably need to adjust the camera. Yes, I do. So, here you are. So, first thing you do is you push these all the way in, and then you tighten slightly. This doesn't need to be torqued. Just it's a control knob. You control when you lose it, these will come out, and when you tighten it, they will be held in place. Okay, so you push them all the way in, and then you tighten this knob just slightly. There is no need to use extra force here. So then you put this into the hole you are going to measure, put it a little bit sideways like this, and then you let it go like that. And then while having it there in a slightly tilted position, then you tighten this. Not much, just a little bit. Then you push it. Oh, now it dropped there. Okay, not a problem. So, and after that you have the measurement copied here. So now we can check with our micrometer what this measurement actually is. And There are different styles for holding this. This is not a very good micrometer. It's a horrible shape, and therefore I have some difficulties holding this. But the principle is that you support this anvil end somehow, and then you screw this in, but you don't use any force. You wiggle it around a little bit until it barely touches. Okay, now it was not in the center. Okay. Okay, the measurement is lost, but you have to keep. Okay, let's do this again. So, these in, tighten, the measurement tool there, loose, it snaps in place. Then you tighten this, not by force, just tighten. Then you pull it over, and then you have the measurement copied here. And then comes the hard part, so measuring it in your micrometer. And this should be straight here between. And now it's really a feeling thing. How you, I have a very good belly for this one. Okay, it's like a table. So you feel it, and this one seems to be, well, 32.65 millimeters. 32.65, yeah. Well, of course, you need to do it again. A few times, so let it loose, push all the way in, tighten, slightly tilted, loosen, not too much, and then when you have tightened it and it's in an angle like this, just pull it over, and then you have copied your measurement here, and now we can measure it again. And this time 68, so 32.68. Well, it's quite a bit more than I thought. So let's do it one more time. Let's see if we get a variety of results. And okay, there you are. And these tools need a feel. You need to feel them. I have learned that this is really a feeling thing. And yeah, now it's 75. I'm sorry, it's 67. So it's around 66, 67. So 32.66, 67 in that range at the moment. So let's measure it one more time. I believe it is actually the actual reading would be something like, it should be around 67 would be my guess here. Now let's see what we got here. And then yeah, it's 67. So I got at least 2 times 67, some 66 point something. So my best guess here is 67. Okay. And if you want, you can use the quesometer also, like this. But this one doesn't give you accurate results. You have to put it on the other end and then wiggle a little bit, and then try to make it. It should be really straight for the first, and if the hole is deep there, what you need to measure, these are impossible to use. Well, what do you see? It shows quite near. Hopefully this focuses. It's 67, quite near. But well, I trust the snap gauges and the micrometer more than the squazometer because it's really hard to get in place. Okay, so now we know where we start. I make a note in the paper because paper you need to put it if you want to remember everything. You are error prone. You make errors. Okay, so let's start reaming. Okay, now the first thing to do here is not to drop the workpiece, but to adjust the reamer. So the further it's down, the larger it will get. So I will loosen it down with my nice wrench, and then I tighten it half turn. I don't know what this, you have to be really careful when you do this, and then you tighten the downstairs again. Well, I do it this way. You could put this in a handle and ream it that way. But it doesn't matter which way way the reamer is rotating in your hole. You could also rotate the workpiece. In this case, it has a very nice handle. So, it would be really awkward to put this everything in my lathe because this is huge, this shaft. So I put it securely into my vise and then I put. So now it should be 1/2 turn tighter as earlier. I already adjusted and made one pass, just not to fuck up. Oh. 1/2 turn is quite a lot, so we need to probably. And now, whatever you do, don't turn it backwards. Okay, we need to back this up. It's quarter turn is better. 1/2 turn is too much because it requires so much strength. So we back it up, quarter turn, like that. And then we put there. So, okay. Now it's tight. It doesn't need to be super tight. Just tight enough that it doesn't wiggle around. Okay, now we try it. It was, oh, yeah. Yeah, quarter turn is suitable. The sound is typical for bronze. It's still quite heavy. Yeah. I think I need to do only not 1/2 turns. Okay. It's true. Yes, that's. Oh. Okay. I can tell you the hole looks a lot better already. The surface finish is absolutely gorgeous. And now it was quarter a turn, and now since we already made the first few centimeters with With incorrect size, we need to do a little bit more here before I measure. So about there, and tighten up. So now, one more time, boys. Okay, this time it's really a lot easier. So I wish you could see the surface finish inside here. It's totally different from the original. Original. Okay. Now I'm going to measure it. So it was half a turn, and now we see where we are at that. How much did it affect the diameter? So we do it this way. Put it here. It's yeah. It looks like every quarter turn of this is 5/100ths of a millimeters away from diameter. Okay, so if my calculations are correct, so now it's 80. It should be after this operation, what I do now, here, so 1/4 turn, and then tighten here up. It should be 85. So my estimation was that it is now, it was 80, 30, 32.80. Now it should be 32.85. Hopefully this focuses, so you can see it's quite near. It's not exactly, it's 1/100th of a millimeter smaller. Exactly the same result here. If we can focus here, it's exactly the same result. So at the moment we are at 32.84 millimeters. $80. Again, as you can see, it's again 88. So we have a few more to go. Well, I go this out of camera, but you probably got the idea. Well, the idea that it's, as you can see, it's heavy. Okay. Well, after a lot of sweating and swearing, luckily we got this not in the camera, so yeah. Now I do a measurement. I have done this already, but I show you. So There is the copied measurement, and then we look what we are at. Okay. The first measurement here will be, it's a hair over. Really a hair. Maybe, I don't know, this one doesn't, well, it does measure the tenths. It will be here, well, 2,000ths of a millimeter according to that one, but I don't trust that one. With this device I trust only the hundredths of a millimeter. That's the accuracy of this thing. Nothing more. Everything else is just guessing. But it's a hair over. Well, now it looks like it's a hair under. As you can see, it's a hair under. So, let's take one more. A little bit different place. Maybe there was something in between. Yeah, of course you need to clean these surfaces and the hole as well. And then do the trick here. Like that. And then I assume this is going to be quite near, but well, it's a hair under. So I believe it's really a hair under. So well, I could try to make it a little bit bigger, but since I'm going to do a shaft here in the lathe, I can actually adjust that one with emery paper, etc. You can do that, and therefore I let it be as it is. It's a good one. So, reaming done. Well, this was the reaming episode. It was totally reaming. And now the next thing we are going to do in the next episode is going to be some lathe work. It will be the axle and shaft. And till then, bye!